Hello, happy Thursday. So today we are looking at a new type of graph called velocity time graphs. But the first thing I'd like you to do, please, is some practice questions. Now these questions use the equation we've done before, which is acceleration, v take u over t. Do you remember? Where a is acceleration, t is time, v is the final speed or end speed, and u is the beginning speed. Or you could say acceleration is change in speed divided by time. So pause the video, have a go, and I shall go through the answers in a sec. Okay, assuming everyone's had a go at that, let's go through some answers. So number one, just eating my lunch. Calculate the acceleration. A is change in speed divided by time, 14 divided by 2, 7 meters per second squared. Do you remember this? So it's m/s squared. Number two, a car accelerates from rest. So u equals 0. Up to a speed of 30 meters per second. So v equals 30 in 12 seconds. So that's time. Calculate the acceleration. So a is v take u over t. 30 take 0 over 12 equals 2.5 meters per second squared. Number three even. Cyclist in the Tour de France accelerates down a hill from 22, so that's u, to a speed of 37, so that's v. This acceleration takes them 2 seconds, so that's t. Calculate the acceleration. A is v take u over t. 37 take 22 over 2 is 15 divided by 2 is 7.5 meters per second squared. Number four, a rocket launching in the Ukraine accelerates upwards from rest, so u equals 0, to a speed of 12, so that's v, in 8 seconds. Calculate the acceleration. A is v take u over t. 12 take 0 over 8 equals 1.5 meters per second squared. And final one, a cyclist accelerates from 0, so that's u, to 8, v in 3 seconds. What is his acceleration? A is v take u over t, is 8 minus 0 over 3. I'm going to have to do that in my calculator. I don't know what 8 divided by 3 is. It is 2.7, or 2.6 occurring, meters per second squared. Next bit. Is this acceleration higher than that of a car, which accelerates from 0, so that's u, to 30, so that's v, in 8 seconds. So the car acceleration, v take u over t, 30 take 0 over 8 is 3.75 meters per second squared. So the bike had 2.7, the car had 3.75. Clearly the car is higher. Okay, so if you can please title and date for me. It is velocity time graphs today. It's not the 17th of December, so if you can please write whatever day it is when you're seeing this, that would be lovely. Now you have spent 2 lessons looking at distance time graphs, and today we are going to look at something very similar, but we're going to look at a graph with time on the bottom again, but this time speed or velocity up the side. Now remember that velocity is just the vector version of speed, so it's just got a direction with it. Now these are not hard, but they are very easily confused with distance time graphs. So you must be very, very careful when you are doing questions that you actually look at what the axes are on the graphs, because if you don't look, you will answer about the wrong type of graph. So my biggest tip here is look at what type of graph you are looking at. So I'm going to do something very, very similar with each of these, and I'm going to talk you through what different lines on these type of graphs mean. You don't need to make any notes, and then at the end I will say, right, here's all of the types of graphs for you to make notes on. So I'll talk you through them one by one first of all. So the first one is, have a look at this. We've got a speed time graph here, and you can see that there's a straight line here. So the speed, and for the time being I'm going to use speed and velocity interchangeably, is not changing. So here, a flat line on the graph means that the thing is moving at a constant speed. So it might be going at 3 meters per second and it just stays at 3 meters per second. I'm going to charge my pencil whilst I'm talking. Right, the next one. Here, you've got something that is getting faster and faster and faster. And I can tell that because the speed is going up. So we say it is accelerating. When you get a diagonal line on the graph, it is accelerating because the speed is increasing. Right, the next one is a bit weird. Have a look. Can you see the fact the line is actually at 0 at the bottom there? And that is because the object has not got any speed. So we say if the line is at the bottom, it is stationary. Remember, stationary means not moving. And the final one I'm going to show you is this. Here, can you see the speed is getting less and less because that arrow is pointing downwards? And so we say it is decelerating. Remember, decelerating means getting slower. So they were all me talking through. Now here you've got the notes that you are going to take. Let's just get rid of this. Now just a quick note. Can you see that funny grid pattern at the back of the graph? You do not need to do that. You don't need to put the grid in. You just want the lines of different colours and labelling them. So please pause the video and label those. Okay, the next bit we're going to look at is here is a giant speed time graph, and you can see it has lots of different lines. So what I would like you to do for me, please, is in a second, pause the video and then mentally just look at each section of the graph and say what's happening. Is it going at a steady speed? Is it getting faster or accelerating? Is it getting slower and decelerating? Has it stopped, etc.? So just pause the video and mentally say which bit is, what is happening where. Okay, so what I'm going to do is I'm going to circle all the different bits that are doing different things. So you can see it starts off here and it's got a flat line. Now the flat line, so let's say in blue, is a constant speed. So the speed is not changing wherever I circle in blue. So let's find all the flat lines. Oh, I found another one here. So you see here it's just under 30 meters per second. The speed is not changing there. Right, I think that might be the only one. So now let's change colour and go for yellow. Let's say it's accelerating, getting faster. So here you can see it's getting faster, the speed is getting faster. Here it's getting faster, accelerating, and here. Lovely. Right, and the last one we'll do is a nice green, and this is going to be decelerating, which means getting slower, remember. So wherever the gradient is going down, that's where it's decelerating. And there you go, 3 places where it's decelerating, getting slower. Lovely, so that was it. Right, there is a little bit more notes, and again, it refers to stuff you've done in maths, so you are going to have to cast your mind back. So, first bit is, how do we work out acceleration? Now, in our last lesson, we looked at distance time graphs, and you found the speed by finding the gradient of the graph. Now, we're going to do exactly the same here. This time, because it's a speed time graph, to work out the acceleration, this time you're going to work out the gradient. Now, acceleration, as I say, it's a gradient. So how do you work it out? Gradient, you draw a triangle. Do you remember this? So draw a triangle on your graph. Here you go. Find the height of the triangle, which is here. It's 10. I know that because I've looked at the axes. Find the base of the triangle, which is 5. Gradient is height divided by base, or you might have said change in y divided by change in x. So 10 divided by 5. And then gives me an answer of 2. Now, it was acceleration that you're working out, so that's 2 meters per second squared. So can you please pause the video and copy out this slide for me? Right, the next thing we're going to do is a bit of a practice question, so that you can have a go. Oh, darn, the answer's there. Okay, well, let's go through it to make sure you're happy. Calculate the acceleration of the object from the graph. So, remember, we are finding the gradient. So we'll draw a triangle. Now this triangle can be anywhere. Could be here, could be here, or I make my life a lot easier by basically making it the whole graph, but you don't have to. So gradient is height divided by base. The height is 20, the base is 5, so it's 20 divided by 5, 4 meters per second squared. Okay, hopefully that was fairly straightforward and you remember that from last lesson. This is our final bit that we're going to look at now, and it's how you calculate distance. So we've done speed time graphs. We know the speed, we just read it off the axes. We know acceleration, so we can find the gradient. But now we want to find the distance that something is covered from the graph. And you do this by working out the area under the graph, which I know is a bit weird. So if you can please pause the video and write these notes, and then I shall explain them. So we can calculate the distance an object has travelled by working out the area under the graph. If the graph is a rectangle, the area equals base times height. So by that, let's do this. Yes. So I'm just deleting stuff so I make it more logical when I explain it. Okay, here's our speed time graph, and the question might say, work out the distance that this object has travelled. Now, what you want to do is work out this area. So you can see it's a nice rectangle that it's formed. And so how do you work out the area of a rectangle? You find the base, which is whatever the time is. So let's say that was 30, the base would be 30. Then let's say that height here, I'm making it up, but let's say it's 10. So height is 10. The area of a rectangle is the base times the height, so you do 30 times 10 equals 300, and its distance, so it's meters. Okay, so hopefully that's fairly straightforward. So you just do the height times the base. However, some speed time graphs don't look like that, do they? They look like this. They're a triangle shape. So you can't just do base times height. Can you remember how you work out the area of a triangle? Some people may remember it as base times height divided by 2, or half base times height. So again, let's assume you had this graph. So if you can pause the video and make notes on this, and then I'll explain it a little more. So let's assume you had this graph and you were asked to work out the distance. You would do the time, which is your base. So let's say that was 10 seconds. Then the height, let's say that was 15 seconds. Okay? 15 meters per second. The area, so the distance is the area, which is half base times height, which is half times 10 times 15, which works out at 75 meters. Okay? So the best way of doing this is to have a little bit of practice. So if you can please pause the video and have a go working out the distance travelled by these objects. Now, number 2, just advanced warning, you want to split it up into 3 different areas, 1, 2, and 3. Work out the 3 separate areas and then add them together to work out the total distance. I'll go through the answers in 1 minute. Okay, question number 1. You're working out the distance. Now, hopefully you can see the fact that this is a triangle. Now, the area of a triangle, distance equals area, which is half base times height. Let's look at the base of the triangle. That's 5. The height of the triangle was 20. So it's half times 5 times, go away, what is this? Times 20, which gives me an answer of 50 meters. Now I'm going to do number 2. I'm going to work out the area for number 1, so this bit, then number 2, then number 3, and I'm going to add them all together. So number 1, so I'm going to call this area 1. It's a triangle, which means half base times height. So that is half times the base is 5. The height is 50. So 5, 50, 250 equals 125 meters. Now let's do number 2. So area 2. You've got a rectangle here, so that's base times height. The base, can you see it's 2 because it goes from 5 to 7. So it's not the base of that rectangle, it's not 7, it's just 2. The height is 50 again, which gives me an area of 100 meters. Area 3 is another triangle, and I'm saying that's about 1. So it's half base times height. Put that over there. Equals half times 1 times 50 equals 25. And then the total distance, I'm going to have to go up here. Total distance equals 125 plus 100 plus 25. giving me 250 metres. I'm just going to underline that. Right, that was quite intense. If you get any time, there is a worksheet on Google Classroom to have a go at. If you have run out of time, because this note-taking was quite long, then don't worry, we've got another lesson tomorrow to have a go at things. Please let me know if you need any help. Thanks, everyone.